Everyone, so this is our lesson on electric fields. All right, so by the end of this, I want you to be able to use models and calculations to explain Coulomb's law and electric fields. So specifically, I want you to be able to explain how charges attract or repel using Coulomb's law, draw models of electric force showing charged particles and force vectors, calculate the force on charges using Coulomb's law, draw models of electric fields using electric field lines, and calculate the strength of an electric field. So this might seem like a lot, but I'm looking for a few major things. Modeling, like drawings, calculations with a couple of equations, and then just to explain what's going on. All right, so what is the electric force? We've kind of already seen this before. In the first lesson, I had you play around with a lab where I have some objects that either have a negative charge or a positive charge, and you have to see what charge does an object have. That's the electric force. When we have two negative objects repel each other, that's the electric force. So this is something that you might have already seen before in class. And so it could be two charged objects, it could really be multiple charged objects. For our class, we're just going to focus on if we have just two charged objects. We'll try to keep it simple. If you took college level physics, they might want you to calculate things for 3 or 4 charged objects. We'll try to be simple here. And the force between charged objects can be calculated with Coulomb's law. So Coulomb was a scientist. His name will come up many times. We even named one of the units of charge after him. And so his equation looks like this. The electric force, is equal to this constant K times the two charges, like how much charge do the two objects have, divided by the distance of separation squared. So you can imagine that there's two charged objects and, let's say they're both positively charged. The force between them depends on how much charge there is on both of them and how far apart are those charges. All right, so if the charges are very far apart, the force will be weak. If the charges are very close, the force will be high. All right. And so this is something that you might recognize from quarter one, maybe, but this was one of the forces that we talked about. We talked about the electric force. And if we have two charged objects that are positive, the forces on them will cause them to repel each other. Now, if I have a positive and a negative, they're going to be attracted to each other. So you can imagine that these objects have charges, and you can imagine that there's some distance apart. And usually we use like a lowercase r to represent the distance between them. All right, so that's where this equation comes from. And not to go too deep here, but the forces on them are equal and opposite. So the force of 1 on 2 is going to be equal to the force of 2 on 1. So some important things to keep in mind. The electric force is usually on a very small scale. We usually are dealing with things that are very, very small, millimeters to centimeters apart. And the charges are usually very small too. So one electron has a charge of 1.6 times 10 to the negative 19th coulombs. Now, if you're familiar with scientific notation or if you're familiar with exponents, you know that 10 to the negative 19th is ridiculously small. But when we deal with objects that have lots and lots of electrons, then the charge can reach a significant amount, but still very, very low numbers here. All right, so one thing I want you to imagine two positively charged particles. What would happen to the force as the distance between them gets bigger? And the other thing I want you to think about is what would happen to the force if one of the particles suddenly gained more charge. Let's say you went from a charge of 1 to 2 or 2 to 4. What would happen to the force in that situation? Again, thinking about this equation, you can kind of think about where those numbers would go, what number here would change, and how would that affect the force over here. All right, so the next thing I want to do is maybe draw electric fields. So when we think about electric fields, we usually think about what would happen if we added a positive test charge. So just a test charge to kind of just test what the electric field looks like. And if we did that here, if I did that on this positive charged object, let's say I put a test charge right here. Okay, if I did that, if I have a positive test charge right next to another positive charge, well, it's going to push this other positive charge this way. All right, let's say I put a test charge here. this positive charge is going to push this positive charge this way. No matter where I put the positive charge, this positive charge is going to push the positive test charge away. And so what you end up with is an electric field. This is the electric field. The electric field just shows you which way would a test charge go, a positive test charge go, if you put it close to another charge. Now this might look different depending on what your charges look like, but right now we're keeping it very simple. We're focusing on a positive test charge. Let's see. Let's talk about negative test charges. So let's talk about that same idea, except now we have a negative charge. So let's say I take a positive test charge and I put it right here. Well, that positive test charge is going to be attracted to the negative charge here. So we're going to draw an arrow this way. Again, I'm sorry if my lines aren't perfectly straight. And I think you kind of see where I'm going here. If I put a positive charge here, it's going to be attracted to the negative charge over here. And no matter where I put a positive test charge, I could put them anywhere around here, it's going to be attracted to that negative charge. So what you end up with is these electric field lines. In this case, all of them are pointing towards the negative charged object. If you ever do a Google search of electric field lines, this will be one of the basic drawings that you see. There's lots of other combinations that you can do. You can have one positive and one negative. You could have a bunch of positives, a bunch of negatives. But right now, this is just a simple idea of an electric field. In fact, let's just do one more. This is a common way to kind of think about things. So a positive charge and a negative charge. Now, what we know about these two charges already is that if there's a distance between them, they would be attracted to each other. So there's a distance between them. This is positive, this is negative. There's an attractive force between these objects. Let's just imagine that they're fixed. Let's imagine that they can't go anywhere and they're just stuck where they are. And in that case, we would have an electric field that kind of just stays between these two objects. And what would that look like? Well, we can kind of draw that by using, again, a positive test charge. Let's imagine that I put a positive test charge right here. All right. It's going to want to get away from this positive, and it's going to want to go towards the negative. So it's just going to shoot over this way. What if I put a positive test charge here? Well, it's going to want to go away from the positive, but then it's going to want to get to the negative. So it might follow like a curved path towards the negative. Now, the path that the charge follows isn't exactly what it would follow in real life. The electric field lines are just kind of showing if you put a charged particle anywhere, where would it start moving towards? So if I put a positive charge here, it would get away from the positive, but then it's going to want to get towards the negative. So we have a field line this way. And I think you can kind of see where I'm going here. This actually looks very similar to what a magnetic field looks like as well. If you've ever seen an image of a magnetic field, it would kind of end up looking like this. And it's actually very similar to the picture that you saw on the opening screen of this presentation. These are what the electric field would look like, and we can show the electric field by drawing these electric field lines. Again, it's just supposed to show what would happen to a positive charge, what kind of force would it feel if it was a positive charge. So for example, if I put a positive charge right here, it might want to shoot this way. If I put a positive charge right here, it's going to want to start going this way. If I put a positive charge over here, it's going to want to go this way. All right, it's going to kind of follow these curved lines towards the negative and away from the positive. All right, so, and again, this is actually what I was trying to draw. Maybe my picture wasn't as nice as this, but the strength of an electric field can be calculated by taking the positive test charge and dividing it, the force on the positive test charge, and dividing it by the strength of the charge. That sounds kind of funny, so let me just show you the equation. Basically, the electric field is equal to the force on the positive test charge divided by how much charge is on that positive test charge. So if you put a charge close to another object, it's going to feel a force. And how much force it feels will kind of tell you, will tell you what the electric field strength is. If it feels more force, then that electric field is strong. Another way we can find the electric field of any point from a charged object is if we know the charge on the object. So let's say I have an object and I know the charge of that object. I can calculate the electric field around that charge. So I have a charge which is Q. I have this constant which is K. And if I know how much charge I have, I can take any point away from that charge. I can take any place around that charge. So let's say I have a positive test charge. Let's say I have a charge right here, and let's say I'm some distance away over here. If I know the charge on Q, and I know the distance R, I can calculate the electric field strength by taking this constant K, multiplying it by the charge of Q, and dividing it by the distance squared, which is R. Let me just make my little point a little bit rounder here. Okay, so that's the general idea for electric fields. I'm really sorry that this video was so long, but hopefully this was all useful and for you kind of imagining what's happening when we take positive and negative objects. Why are they attracted to each other? Well, there's a force there. And the electric field kind of shows you what does the force look like at any point. And if you know the force at any point, you'd start developing an idea of what the electric field looks like. All right, good luck with your practice problems and anything else that you need to do for this lesson.